Grade 11, Mathematics Paper 1, Common Test, Question 2. Question 2. In 2.1, they ask you to simplify fully without the use of a calculator. In this case, we are working with a fraction, so I'm going to get the highest common denominator. The highest common denominator in this case is 2 square root 3, so again 2 square root 3. Looking at the first fraction, I noticed that I need to get a 2, so 2 times 2, that is 4. Looking at the second fraction, I need to get a square root 3. Square root 3 times square root 3 is 3. Now I can subtract the two fractions, so I'll get 1 over 2 square root 3. And then I'm just going to times the numerator with the numerator and the denominator with the denominator. I'll have 1 times 1, which is 1. 2 square root 3 times 2 square root 3 would be 4 times 3. And then finally, my answer would be 1 over 12. For 2.1.2, we're working with square roots. Because you need to simplify this without the use of a calculator, I always suggest to just see if you type it into your Casio calculator, what do you get? You would notice you get 6 and then square root 2, which means the square of 6 would have been 36 times 2, and that will give you 72. We're going to do exactly the same for the denominator. I noticed that, hey, it needs to be 4 times 2 plus 49 times 2. And then from here I can simplify, so I'm left with 6 square root 2 over 2 square root 2 plus 7 square root 2. I can add the like terms together for my denominator. 2 plus 7 square root 2 will give me 9 square root 2. From here I can cancel out the square root 2, so I'm left with 6 over 9. Simplify that, 2 over 3. For 2.1.3, we have a fraction divided by a fraction, so I'm going to flip the second fraction so I can have a times expression. So I'll have the 6 and then in brackets n plus 1, as well as the 3 to the power of n and in brackets n minus 1. And then I'm going to times it by 3 to the power of n squared minus 1 over 2 times n to the power of n plus 1. And then I'm going to change every number that is not a prime number into its prime factors. So I have 2 times 3 to the power of n plus 1. I'm also going to expand the brackets. So I have 3, and then n times n is n squared. N times negative 1 is negative n times 3 to the power of n squared minus 1 over 2 times 3 to the power of 2, but the 2 needs to times with the n and the 1. So I have 2n plus 2. From here I'm going to take the bases, starting with the 2. I have a 2 to the power of 1. And the other one that has a base 2 is below the line, so I'm going to subtract it by 1. Times 3 to the power of 1. And then I'm going to add everything above the line, so that will be plus n plus 1 plus n squared plus minus, which is just minus 1. And then below the line I'm going to subtract everything, so it's going to be negative n squared. Negative and a negative is a positive n minus 2n minus 2. From here I'm just going to add the like terms in the exponents. For the 2, I'm left with 2 to the power of 0 times 3 to the power of negative 1. Since I don't want to end with a negative exponent, I can change it to 1 over 3. For 2.2, I'm going to solve for x. I notice on the left-hand side, I can take out a common factor of 3 to the power of x. So I'm left with 5 plus, and if you take a 3 to the power of x out, you're still going to have a 3 to the power of 1 left, equals to 216. Then we'll have still 3 to the power of x, and then 5 plus 3 is 8, equals to 216. If I want to get rid of the 8, I'm going to divide on the left-hand side by 8, as well as on the right-hand side by 8. And 216 divided by 8 is 27. Then I'm going to get both of them on the same base, which would be 3. And 3 to the power of 3 gives me 27. Because in its equation and the bases are the same, I can drop it, and then I'll have the exponents x is equal to 3. For 2.3, if 6 to the power of x is equal to 5, calculate the value of 18 to the power of x divided by 2 to the power of negative x. Here I'm going to change everything that is not a prime number into their fractions. Starting with the 6. The 6 changed into 2 times 3, and then I need to give both of them the exponent x. So it will be 2 to the power of x times 3 to the power of x is equal to 5. And then for the 18 to the power of x over 2 to the power of negative x, I can change the 18 to 2 times 3 to the power of 2, also giving them the exponent x. So it will be 2 to the power of x times 3 to the power of 2x over 2 to the power of negative x. And then because my bases are the same, I can either subtract or add the exponents. So 2 to the power of x minus x times 3 to the power of 2x. That gives me 2 to the power of 2x times 3 to the power of 2x, which is basically 2 to the power of x times 2 to the power of x times 3 to the power of x times 3 to the power of x. And since we know that 2 to the power of x times 3 to the power of x is 5, we have 5 times 5, which is 25. And that is the end of question 2.